what is the value of 2 to the power 5 upon 2 to the power 3? So we know that I can express 2 to the power 5 as 2 multiplied with 2 multiplied with 2 multiplied with 2 5 times, right? Of course, I can express 2 to the power 3 as 2 multiplied with 2 multiplied with 2. Now you can cancel out 3 2's from the denominator and 3 2's from the numerator. So our answer will be equal to 2 square, right? 2 2's will remain and that is equal to 2 square. 2 into 2 which is equal to 2 square, that is 4. Okay. Similarly, let us see 3 cube divided by 3 square. I can express 3 cube as 3 multiplied with 3 multiplied with 3 divided by 3 multiplied with 3. Okay. Now again you can cancel out 2 3's from denominator and 2 3's from numerator. So our remaining will be 3. Okay, which is equal to 3 to the power 1. Now next one, 3 to the power 4 divided by 3 to the power 4. So I can express this as 3 multiplied with 4 times. 3, we are multiplying 3 4 times. So something like this divided by, you can cancel out the entire 3's from the numerator and the denominator and the rest will be equal to 1. So this 1 is nothing but 3 to the power 0. Okay. Now what is 5 to the power 4 divided by 5 square? That is equal to 5 multiplying 4 times divided by 5 multiplying 2 times. You can cancel out 2 5's from the denominator and from the numerator. The remaining will be 5 multiplied with 5 which is equal to 5 square. Okay. And that is equal to 25, whatever. So in general, what is a multiplied with 3 times? We are multiplying a 3 times divided by, I am multiplying a 2 times. You cancel out 2 terms, right? 2 a's from the numerator and the denominator and the remaining will be equal to a. So based on this result, I conjecture something. I have a to the power m upon a to the power n, that is equal to a to the power m minus n. You can see that here we have 5, here we have 3. So 5 minus 3 which is equal to 2. Here we have 3, here we have 2. So 3 minus 2 which is equal to 1. Here 4 minus 4 which is equal to 0. Similarly 4 minus 2 which is equal to 2. So based on this result, this was our conjecture, a to the power m upon a to the power n, that is equal to a to the power m minus n. We can see some more examples based on this result. I have 2 to the power 3 divided by 2 square. Based on this result, we can express this as 2 to the power 3 minus 2. So we have 2 to the power 3 minus 2 which is equal to 2 to the power 1 and that is equal to 2. Similarly, we can go for next one, 2 to the power 5 upon 2 to the power 3 which is equal to 2 to the power 5 minus 3. So that is equal to 2 square, that is 4. Now 7 to the power 14 upon 7 to the power 3. So 7 to the power 14 minus 3, 7 to the power 14 minus 3 which is equal to 7 to the power 11. Next one, 7 cube upon 7 raised to 4. Yeah, a beautiful one. 7 to the power 3 divided by 7 to the power 4. Here we have 7 to the power 3 minus 4. Right. So what is 3 minus 4? We know that 3 minus 4, that is negative 1. So the exponent, entire exponent turns to be 7 raised to minus 1. Okay. So what is 7 raised to minus 1? I can express 7 raised to minus 1 as 1 upon 7. Why? We can see that because 7 raised to minus 1, this is nothing but 7 raised to 0 minus 1, right? 7 raised to 0 minus 1 is 7 raised to minus 1. And this one is, what is this one? 7 raised to 0 minus 1. By using our method, a is 7 here, m is 0 and n is 1. So we can express 7 raised to 0 minus 1 as 7 raised to 0 divided by 7 raised to 1. So this is 7 raised to 0 divided by 7 raised to 1. And that is equal to 1 by 7. Because 7 raised to 0, we know that that is 1 and any number raised to 0, that is 1 and the remaining is 7. So that is 1 by 7. Yeah, we can go for next examples too. What is 10 raised to minus 2? I can express that one as 1 over 10 square. What is 10 raised to minus 3? That is 1 by 10 cube. What is 10 raised to minus 5? That is 1 by 10 to the power 5. What is 8 to the power minus 5? That is 1 by 8 raised to 5. What is 9 raised to minus 2? It's equal to 1 over 9 square. So what is 3 raised to minus 5? That is 1 by 3 raised to 5. Again, let me revisit again. Why this reason? Why this is happening? It is only because of, we know that 3 raised to 5 minus 5, this is nothing but 3 raised to 0 minus 5. But what is 3 raised to 0 minus 5? This is nothing but, again it is 3 raised to 0 upon 3 raised to 5 using our exponent rule. This is of the form a raised to m minus n. We are only picking same base exponents. Okay, we are not going for 2 as base and other base as 3. We are only picking the base 2. If it is 2, we are only sticking on into 2. So here we have same base and different exponents. So here 0, 5. So 0 minus 5, which can be written as 3 raised to 0 upon 3 raised to 5. So what is 3 raised to 0? That is actually 3 raised to 0. That is actually 1. 1 upon 3 raised to 5. So now you have see how can we divide two fractions, I mean two exponents. If we have a raised to m as an upper exponent and another exponent as a raised to n, we can do it by using our method a raised to m minus n. So that was our conclusion.